I'm lost. Hello there, Mr. Lost. I need to get to the city. How do I get there? The city? That way. How do you know? Did the sky tell you that? Yep, that spoon right there.
For years and years now, people have looked to the skies to figure some things about the earth. Now, be it the sun to figure out the time of the day, or the moon to figure out the progression of a month, even to the stars to figure out the location on earth. The sun, sure. When it rises, it's morning, and when it sets, it's night. But what about the moon and the stars? How can the moon tell us about the month? And more importantly, how can the stars tell us our locations? Well, let's find out. We need to learn about the moon first. Let me get my good friend Avinash to tell you about how the moon works.
Hey, I have a question. How do I keep changing shape constantly? Sometimes I'm a curved shape. Sometimes I'm complete. How is that happening?
Well, that's a nice question. So when I was a young kid, I used to think that this is because there was some giant space monster that was eating the moon bite by bite, and somehow the moon used to grow back by itself. Well, the truth is, there is no such space monster. It happens because the side of the moon that's facing the Earth gets less lit or more lit based on its position as it moves around the Earth. You know what? Let's do another experiment to understand this. Now, this is the experiment. Now, I want you to imagine that I am floating somewhere in space, and that bright light over there is the sun. This white ball is the moon, and I am the Earth. I repeat. The bright light is the sun, this white ball is the moon, and I am the Earth. Let's neglect the rotation and the revolution of the Earth. We know the Earth rotates about its axis and it goes around the sun, but let's neglect that for now. It's not important. What is important though is the movement of the moon around the Earth. So what does the moon do? The moon also rotates and revolves in such a way that only one side faces the Earth all the time. For example, it does something like this. So if this is the moon and I am the Earth, it goes around the Earth like this. But the thing is, it's not exactly like this. What I mean is that the plane of revolution of the moon is slightly tilted. What they basically look like is like this. So the moon moves around like that. So as you saw, the plane of revolution is slightly tilted like this. Now let's say this is the first position in its cycle. As you see, it's just in between the Earth and the Sun, so therefore you can't really see it from the Earth, right? Because the side of the moon that's lit is facing the other way. So it's just impossible to see the moon when it's like this. Okay? But then the moon starts moving, right? It starts revolving around the Earth. So in about 3 days or so, it comes to this position. You see that you can see a part of the moon, right? A part of the side that's facing us is lit, a very small portion, and it's curved like this. This phase is called the crescent moon. It's very common, very popular. More specifically, it's the waxing crescent. Now, of course, you can ask me why it's called the waxing crescent. I'll explain that a little later. But understand that this is the crescent moon. Okay? Now the moon starts moving again, or it continues to move in its cycle. And in about 3 days' time, it reaches this position. This phase is called the first quarter, because the moon has completed approximately about a quarter of its cycle. And what you see is just that half of the side that's facing us is lit, exactly half, right? Okay, and the moon keeps moving again. This phase is called the waxing gibbous. In this phase, you see that about 3/4 of the side that's facing us is lit, or a little more than half of the side that's facing us is lit. Now, this portion you see probably the most popular phase of them all, maybe even the most beautiful. You see that the side that's facing us is completely lit, and this phase is called the full moon. This portion, the moon has completed exactly half of its cycle, and now it starts coming back towards the sun. And in about 3 days or so, is what it reaches, and this is called the waning gibbous. Now again, it's a gibbous because about 3/4 of the side that's facing us is lit. But it's a waning gibbous because it's on the other side now. And again, why exactly waning? I will explain that a little later. As the moon moves even further, the next phase we reach is called the third quarter. And in this phase, exactly half of the side that's facing us is lit again, just like the first quarter. Now this phase is called the third quarter because the moon has completed approximately 3/4 of its cycle around the earth. As it moves further, it reaches a phase called the waning crescent. Again, this is very similar to the waxing crescent, but the difference being it's on the other side. Finally, the moon reaches the position where it all began, the phase called the new moon. So after this, the cycle just continues to. And this is why you see different shapes of the moon in the night sky. Now let me explain why we use the words waxing and waning. Now the meaning of the word waxing is increasing. And similarly, the meaning of the word waning is decreasing. Okay? So now, let me explain. So the reason this position or this phase is called the waxing crescent is because the size of the moon in the night sky increases as the moon moves like this, right? Or you can say that the side that is facing us gets increasingly lit as the moon moves in this direction like this. So therefore, this position is called the waxing crescent, and similarly, this phase is called the waxing gibbous. But now, after we have the full moon, when the moon comes this side, the size that is facing us is getting decreasingly lit. Or you can say that the size of the moon in the sky is reducing. So therefore, this side is called the waning side. And that's why this position is called the waning gibbous, and this position is called the waning crescent.